Welcome to Program Analysis Corner.
In this video, we're going to do a quick look into a new fuzzer called Atheris, which is a coverage-guided Python fuzzer that is based on the libfuzzer core engine. It's a very new project, and we can see that it only has 2 commits so far, and those were just committed 2 days ago. Naturally, we can think of it has probably been developed internally in Google for a little bit more than a little while before they released the commit, the project. Okay, so what we will do in this video is we will install Atheris, we will try to run it on a few samples, and then we will maybe look a little bit at how the code here looks, because there is not a whole lot of code in the fuzzer, but there are still a few bits of C++ code here. So in order to install Atheris, we can simply install it by way of pip, but first we need to make sure we have the necessary Python environment installed, and in particular we need to have this python 3-dev package. So I will just go ahead and install that. And over here on my right, we are in a Docker image, just a rather clean Docker image with a Clang version 10 installed. Okay, so now let's try and install Atheris. And we're collecting it. It should be going fairly smooth. Okay, so the procedure now finished, and we have installed the Atheris fuzzer. So now let's try and go through one of the examples that they have here directly in the README, where they have provided an extremely simple sample of how to use the fuzzer. So let's just create a test.py file, go into it, and what we can see in this example is that we simply import the Atheris module, and we then have 2 lines here that sets up the fuzzing essentially. So we have here a call to setup on the Atheris module, where we give first an argument, namely sysargv, and then we also have a call here to test one input. And sorry, not a call, but the second argument to the setup function here is the function that we have here, test one input. So that probably means that when we set this up, the second argument here will be the entry Python function of our fuzzer. So this will be the random data that is passed from the fuzzing engine to our fuzz driver. And then we simply have a call here to fuzz, which triggers the fuzzing engine to execute. So I'm pretty sure this won't compile, since we actually need to have this sys module, but let's just see if it works. Yeah, so we just need to have sys here, and let's then try and run it. And we can see that it runs fairly fast, but we see we got a uncaught Python exception, and it's a runtime error, and it gives us the string here, badness, and we can see that's exactly the error that is being thrown here. We can also see that we get a crash file here. So let's see what's in that file, and most likely we would like to see that at least there are the 3 characters BAD. And we can see that that's indeed the case. So we have a clean seed file here of 3 bytes that corresponds to bad. So that's the very most simple example of running Atheris. Okay, so now let's try and modify the example a little bit and see how, just get a little bit better feeling of how the fuzzer works and what it's capable of doing. So let's add a bit more checks inside of this test1 input function, just to see if it can get past our checks. And let's just add a few simple checks on the data, such that it becomes a little bit more difficult for the fuzzer to reach it, or at least becomes difficult in the sense that it has to pass more constraints. And if you simply return peacefully from the test1 input function, then it means that there's no bug occurring in the fuzz iteration. So simply having a good return from the test1 input is just returning without throwing an exception. Okay, so let's do as follows to see if we can spell out a little bit a long boom word. So if the first character is not equal to an uppercase B, then we simply return. And we do this for a few of the characters. So let's say if the second character in the data buffer is not equal to an uppercase O, and the third, and so on, as follows. Let's see if we can just get a little bit more characters than previously, then we will throw the exception. So in this case, the constraints that the fuzzer has to find is that the length of the data has to be 8, because if it's not 8, we return gracefully, and then we also check on the first 5 characters of the buffer. If they are not equal to boom in total when spelled out, then it's only in that case that we will throw our runtime error, and that means it has a little bit more checks to go through in comparison to before. So let's just see how the fuzzer performs with this new fuzzer entry point function. And it runs, and we can see that it has this regular LLVM, libfuzzer output where we can see the coverage, and we pretty quickly get up to the Python exception here. So we see our badness exception, and we can also see here that the boom characters are spelled out for us. So we can do a quick look at the specific buffer as well, and we can see that the length of it is indeed 8 bytes too. Okay, so that worked pretty well, and the simple example was fairly straightforward. Now let's try and do one of the example fuzzers that they have provided. So these should be a little bit more extensive than the other ones that the one we just did. And specifically, let's try this YAML fuzzer. So they have a YAML fuzzer here, and we have the same one in, well, first we have to clone the repository. So let's clone it. And there we go with that. And then let's move into the repository and into the examples and go into the YAML. Okay, so here we have a fuzzer that is this fuzzer is an example of looking for weird exception in ruaml.yaml, which is the package that we are fuzzing. And we can see here that we have a somewhat similar setup. We have an import of the Atheris module here. We have a test1 input function, and we have a main function here, and this main function is called down here. So when the if we launch this script, this function will be called, and we can see that we have the same setup as previously, where we have an Atheris that's set up, and we have the second argument to be our input function, and these are the random bytes from our fuzzing engine. And we then launch the fuzz execution right here by calling the fuzz method in our Atheris module. And we can see that then a bit of stuff happens in here. So essentially we create what is called here a fuzz data provider, and what that can do for us is it can help us convert a set of these raw bytes from the fuzzer, which are these input bytes. It can help us convert that data into more useful data types. So for example, a Unicode string. So we can this kind of fuzz data provider is something that can translate the raw bytes from our fuzzer and give us proper data types that are seeded by the random data from the fuzzer. And we can see then we simply just call some function in the our YAML module with the Unicode string that we get here. And we can also see here, if we catch a YAML error, then we gracefully exit the test1 input function. And what that means is that it's good if the library throws a YAML mistake and that does not a YAML error, and that does not constitute a bug as such. But if we get other bugs, if we get other exceptions here, that might not be the best. So let's try and run this fuzzer. And we need to install a package, and I think this is the one. Like this, and that should be fine. And now we can try and run this fuzzer. And it goes, and let's stop it there. And we can see that essentially it has a lot of coverage. So in comparison to like regular lib fuzzer function, this is on for C and C++. We can see that the coverage quickly goes up, and that's in many ways a result of the fact that we are also fuzzing a Python module here. But nonetheless, we can see that it works pretty well in that it does increase coverage, and it's a fairly simple fuzzer that targets the load all function here in the RYAML module. I will not run it for too long in case a bug happens, and that might not be the best to showcase. Okay, so that's a fairly simple fuzzer. As we see, we have simply just a few calls here, but conveniently we have a function that gives us the Unicode we need to pass into our data. And in case a bug is found, that we have to pass into our target function. So this here is the function that we are trying to fuzz. And we can also see that it conveniently writes out a bunch of data if actually another exception is catched, and that is also considered a bug, which we can see because we have this raise call here. Okay, so that's it for the examples I wanted to go through. Now I want to look a little bit at the source code of the Atheris fuzzer. And in particular, we can see that there are 1, 2, 3, 4, 5, and 6, and also 6 C++ files, and one of them being a test file here. So we have 5 different C++ files that essentially make up the Atheris source code. And I would like to go through 3 of them. First, we have this atheris.cc file here. So let's look at what's inside. And we can see here that these are essentially the Python bindings to the Atheris module. So if we just look at our fuzzer again, we can see we have this function, atheris.setup and atheris.fuzz, which are the exact functions that you see bound here. And then we have this fuzz data provider, which is the one we create right here. And we can see that a various set of functions are bound to that module, and these are in particular, for example, consume Unicode, which we can then find over here, exactly right here. So here we can see the bindings that are set up by the Atheris module. And I'm no expert in Python bindings, so don't quote me on too much of the talk that I do on the Python bindings. But we can see nonetheless that it's a very simple C++ module that exposes the C++ backend of Atheris. Now if we go into the libfuzzer file here, I will just open the Atheris again here, then we can see that in the libfuzzer C++ file here, then we can see that the various functions here, let's say the setup here, is declared in this file. So in the libfuzzer.cc, we can see the setup function here is declared, as well as we have the fuzz function here. And in particular, if we look at the let's look actually at the fuzz function first. So we can see one of the core things that the fuzz functions does is that it calls into this LLVM fuzzer run driver, and it gives this argument test1 input here, which is a function pointer to this function up here. And what this function does is essentially it just calls into a function here called test1 input global. And this test1 input global is the one that in practice calls into this function right here. I'm pretty sure that's the case. And yeah, so it gives the bytes here, so the Python bytes here, which correspond to the random data that is given by the regular libfuzzer core entry point function. So let's get back to this test1 input global function, which we can see is defined up here within the setup function. And here in the setup function, we can see that the test1 input global is assigned the value of test1 input, and test1 input corresponds to the second argument here to the setup function, which is the one we have right here. So here we can see kind of like the back end of the Atheris fuzzer and how these things actually are connected very simply by the C++ modules in here. And we can also see that it is essentially just a bridge and an interface to the libfuzzer core. So if you're familiar with the libfuzzer core, some of these functions will be familiar to you. Okay, and finally, I would like to look at the a little bit more at this fuzz data provider module, and that's the function, the C++ function, file that you see here. And we can see that inside of this C++ file, we have all of these various consume functions, which corresponds to the functions that are available in our fuzz data provider. And we can see that we have like consume bytes, consume string, consume int, and all of these can be used to extract more nicely formatted Python objects. So we can see here consume int calls into various functions, so like pyint func, which probably returns does return a integer as represented as a Python data type. And we can see that there are a bunch of other consume functions, and essentially there's not a whole lot more. So we can go into these functions and understand them a little bit more, but essentially they are just kind of like utility functions. And we can also get the overview of all of the various consume functions by looking at the atheris.cc file. Okay, so I think that's it for this video, and I encourage you to try things out yourself. It's as you can see, it's fairly easy to get going, and there's quite a bit more to it. In particular, it supports also fuzzing native extensions, and there is an example in the repository with this, I believe here, where they take a Python extension that is written in C or C++, and then they compile it with address sanitizers and so on, and then you also can fuzz it by way of Python. So that's also a cool thing. As you can see here, there's something where they compile it in, I believe they compile it, the extension UJSON, in a way that you also get address sanitizer into your Python extension. Okay, so I think that's it for now, and I hope you enjoyed the video. Thanks.